GRIAS Academy.
100 days, 100 themes, one goal, UPSC Prelims. Hello all, welcome back to the program Mission Surya Phase 3, a STEM revision program where we deal with science and technology and environmental related current affairs completely in Prelims perspective. So let's get started with our today's session. In our today's session, we are going to deal with a second theme of science and technology like completely military dropouts, the military dropouts. So we have seen few fuels regarding things in last two lectures, right? Now for today we have seen the defense technologies and defense dropouts. Okay, now let's start. Our first topic is about the hypersonic missiles. What are these hypersonic missiles? Hypersonic missiles are the weapons which are designed with 5 Mach speed, which are designed with 5 Mach speed and more for easily maneuvering during their flight. Okay, now let's see why it is in use. Means first is India's scramjet milestone. India's scramjet milestone, which is given in May 2026, like the Defense Research and Development Laboratory. The Defense Research and Development Laboratory has in Hyderabad successfully ran a full-scale actively cooled scramjet combustor for over 1200 seconds, that is approximately 20 minutes. Okay, this is a massive leap for India's hypersonic cruise missile, India's hypersonic cruise missile program. Okay, next is LR-M phase 2 trial, LR-M phase 2 trial, which is held in May 2026, where India successfully tested its long-range anti-ship missile, of the Odisha coast, okay, where in the Odisha coast accurately striking a simulated sea-borne target at a range of 1500 kilometers. Next, coming to the global development, Russia has recently developed its Orshink hypersonic missile, while the United States announced the project called Maverick, which is slated for fiscal year 2027. Okay, it is aimed at tracking and intercepting hypersonic threats. Okay, next, let's see what is this hypersonic missiles. These hypersonic missiles travels at a speed of Mach 5 or higher, okay, which is 5 times faster than the sound which the sound travels, that is approximately 6100 kilometers per hour, okay, and can maneuver significantly during its flight. It can maneuver easily during its flight. Okay, now coming to the maneuverability, unlike the traditional ballistics missile, the ballistics missiles which generally we are using it, unlike them, they follow a predictable parabolic arc. They follow a predictable parabolic arc. They can be predictable and they follow this parabolic arc, like whereas hypersonic weapons can change their target, change their trajectory mid flight. When they take off also, when we give a target to it and when it is traveling also, we can change its trajectory. Okay, this is how the hypersonic models have been designed. Hypersonic missiles have been designed so that they can easily maneuver. Okay, next, coming to the altitude range, normally our ballistic these ballistic missiles below the radar zone, below the radar horizon or longer periods they were traveling. But coming to the typically fly at lower atmospheric altitudes, these hypersonic missiles travel at a lower atmospheric altitudes like 20 to 100 kilometers. Okay, next, coming to the stealth. Stealth is the plasma shield, where at speeds exceeding Mach 7, not 1, 2, when the speed exceeds Mach 7, when the speed is exceeded by the hypersonic missiles, what happens? At extreme air friction, the air gives the friction, right? At extreme air friction, these missiles, the surrounding air into a state of ionized gas. It converts the surrounding air into an ionized gas, which is called the plasma. Okay. This plasma shield absorbs radio frequency waves. This plasma absorbs the radio frequency waves, making the missile virtually invisible. It makes the missile visually invisible to traditional radar systems. To traditional radar systems, this missile will be invisible due to this plasma shield, because it absorbs the radio frequencies. Okay. Next, and it is, although it is good for us, but even it is boon also, like it interrupts the disturbances like guidance challenging, like for communication also. If the missile is not visible, how can we target it, right? This is also one of the major drawback of it. Okay, next. Let's see few types of hypersonic weapons. What are there? UPSC frequently ask this comparative questions on mission technology, where hypersonic machines are primarily divided into two categories. What are there? The first one is HGV, the second one is HCM. What is HGV? HGV is hypersonic glide vehicle. Hypersonic glide vehicle, and HCM is hypersonic cruise missile. Okay, coming to the propulsion, the feature of propulsion in HGV is it is launched by a conventional rocket or ballistic booster. It has one vehicle has to mean the launch vehicle has to be there for this missiles. Okay, into the upper atmosphere, then detaches from the rocket and then glides upward to the target. Okay, when coming to HCM, this hypersonic cruise missile, these are powered continuously by air breathing scramjet engines, throughout its atmospheric flight. Coming to the trajectory, it uses aerodynamic lift. It uses the aerodynamic lift to glide and skip along the upper atmosphere, that is from 40 to 100 kilometers of range. Coming to HCM, it flies horizontally in the lower atmosphere ranges from 20 to 30 kilometers of altitude, much like a traditional aeroplane or a cruise missile. Okay, coming to the examples of India, the first one in HGV is hypersonic glide vehicles is LRASHM, LR long range vehicles, and the Project Dhwani. Okay, the next in HCM examples is BrahMos 2, ETLDH-CM. These two are the examples of hypersonic cruise missiles. Okay, moving on, and let's see this first. These three are the engines: scramjet, ramjet and the turbojet. These three engines, how they differ from the ballistic rockets are, they use the atmospheric oxygen. For the combustion process rather than carrying their own oxidizers. Okay, basically for combustion, oxidizer has to be there. So many rockets use their own oxidizers, which are very heavy in load. They carry it and releases during the combustion process. But these engines, which are used in the hypersonic missiles and all, they use the atmospheric oxygen only for this combustion process. Okay, now let's see. These three engines works on the principle of compression, combustion and exhaust. How? By first they takes the air inlet, in the sense the atmospheric oxygen, the oxygen which is present in the atmosphere is entered into the engine. In the compression stage, what happens? The pressure of the air increases. And during combustion, during the stage of combustion, what happens? The fuel burns, and last in the exhaust it produces the hot gases and produces the thrust to the engine. This is what the engine model is done. Okay, what are the three engines? Scramjet, ramjet and turbojet. Okay, next let's see it detailedly. Now, a few science and tech concepts for prelims, like they might compare of ramjet versus scramjet engines. What are these ramjet engines? They use forward motion. They uses the forward motion to compress the incoming air. When the incoming air is coming, it uses the forward motion. It uses forward motion to compress incoming air. No moving compressor parts are there, but slows the air to subsonic speeds. It slows down the air to subsonic speeds for combustion and works best up to Mach 3 speeds. Till Mach 3 speeds. Okay. Next, Coming to scramjets. Scramjets are supersonic combustion ramjets. Supersonic combustion ramjets which allows the airflow to remain at supersonic speeds. It allows the air to remain at supersonic speeds during combustion, which is essential for sustaining speeds above Mach 5. It is up for Mach 3, right? Now this is for Mach 5. Since it breathes atmospheric oxygen, it does not need to carry any heavy oxidizers as the oxidizer tanks like the ballistic rockets. Okay. Next, coming to the active cooling process, it is a critical survival technology for a hypersonic flight. Okay, when the speed reaches the Mach 6, when the speed reaches at Mach 6, aerodynamic heating pushes the temperatures beyond 2000 degrees centigrade. Imagine the temperature there, 2000 degrees centigrade, too high temperature, where the active cooling involves circulating the missile's liquid hydrocarbon fuel. It circulates the liquid hydrocarbon fuel through the engine walls to absorb the heat before it enters into the combustion chamber. Okay, this is what the active cooling will do. Next, let's see India's hypersonic developmental status. What is the development status in India for this hypersonic missiles? India pursues a dual strategy. What is the dual strategy? It is developing fully indigenous technologies as well as maintaining the strategic joint ventures with the other countries also. Okay. Now, first one is HSTDV. HSTDV is Hypersonic Technology Demonstrator Vehicle. Okay, it is an indigenous unnamed scramjet demonstrator. Indigenous scramjet demonstrated vehicle developed by the DRDO. It has successfully demonstrated sustained scramjet combustion at Mach 6. At what speed? At Mach 6. Okay. Next, LRASM, which is a long range anti-ship missile. Long range anti-ship missile, which is a hypersonic boost glide weapon with a 1500 plus kilometers range, which is often dubbed as a carrier killer. It utilizes an indigenous radio frequency. It uses what? Indigenous radio frequency, which is seeker to track moving naval vessels in its terminal phase. Okay, the next one is Project Vishnu. What is this project? It is a classified DRDO program developing a family of hypersonic weapons, which is notable the ETLDHCM, that is Extended Trajectory Long Duration Hypersonic Cruise Missile, okay, which is designed to fly at Mach 8 speed. Okay, next, coming to BrahMos 2. It is a joint venture project between the India and Russia, which is aiming to upgrade the supersonic BrahMos 1 to hypersonic variant, which is expected to reach the speed of Mach 7. Okay. Next, these are few things. India's hypersonic developmental status. Okay. Next, coming to the global hypersonic landscapes, Russia, which is leading, like it has operationally developed multiple systems, including the Zinhal, which is the air-launched, Zircon is the scramjet HCM, and Avangard, that is the HGV. Okay. Next is China, where it possesses the DF-17 and DF-27, which is equipped with the DF and ZF glide vehicles and the YJ-19 scramjet cruise missiles. Okay. Next, coming to the United States, which is still catching up because many failures have happened during their experiments, because while historically leading in research, while the US is historically leading in the research, it has faced recent test failures, many recent test failures. Like current major projects include long range hypersonic weapons and the hypersonic attack cruise missile. Okay, this is what globally the hypersonic missiles are. Okay, next, coming to the next topic. Our next topic is directed energy weapons. What are these directed energy weapons are of? These are the weapons which are, these weapons are designed in such a manner that they doesn't use any bullets or explosions. Bullets or explosions are not used in these, but however these are used with the focused energy, energy like laser beams, radiations and all. Okay, laser beams and radiations. Okay, now let us see why this direct energy weapons are in news. Durga 2 naval deployment. Durga 2 naval deployment of May 2026 it is. Like India's DRDO is actively adopting the Durga 2, a 100 kilowatt high energy laser weapon. It is using energy rather than using the bullets and explosions. They are using 100 kilowatt high energy laser weapon for deployment on the Indian Navy's Visakhapatnam class steelhead destroyers. Okay, on the Indian Navy's Visakhapatnam class stealth destroyers. Okay, it is currently undergoing marinization to withstand harsh sea conditions. To withstand these harsh sea conditions also, it is being still designed. Okay, next coming to Project Sahastra Shakti. Project Sahastra Shakti in 2025 it has been taken up. Like DRDO successfully demonstrated the MK2A. It is an indigenous 30 kilowatt laser based DEW system at the National Open Air Range in Kurnool, Andhra Pradesh. Okay. Next, what is this direct energy weapons? We'll see. Okay, these directed energy weapons are a class of advanced weapons that are used highly and focused energy rather than any solids or kinetic projectiles like bullets or explosives to damage, degrade or destroy the targets. To damage, destroy or degrade the targets, they are using focused energy rather than using the solid types of bullets or explosives. This is what the directed energy weapons are of. Okay. Now, what is the core principle of it? They convert the electrical or chemical energy into concentrated electromagnetic or particle beams which engaging targets at the speed of light. This is the core principle of direct energy weapons. Next, coming to the primary targets. What are the primary targets of it is drone swarms, loitering munitions, anti-ship cruise missiles and electronic communication systems. These are the primary targets. Okay, next. Let's see laser weapon versus high power microwave weapons. Difference of these two. Okay, for UPSC prelims it is crucial to understand the difference between these two laser weapons and high power microwaves, because these two primary categories of developmental, direct energy weapons will come in the examinations. Okay, because these are even deployed globally. That's why this is very important regarding the prelims perspective. So let's see. First one is the high energy laser weapons and high power microwave weapons. We'll see the difference of these two based on the features they have. The first feature is mechanism of damage. How in high energy laser weapons is it concentrates extreme thermal energy. It concentrates on extreme thermal energy on a pinpoint spot, melting or burning through the physical structure of a target. It burns the physical structure of the target. Example, a drone's airframe or binding its optical sensors. Okay. Next, coming to the high power microwave weapons. It emits intense pulse of electromagnetic energy. It emits the intense electromagnetic energy which is designed to overload, scramble or permanently fry the target's internal electronics. Completely fry the internal electronics of the targets and computer chips. Okay. Next, coming to the target area. The high energy laser weapons, they point target highly precise, hitting a specific tiny spot on a single target. On a single target, it can target the exact point what we have wanted to target. Okay. Next, high power microwaves, how they are area target. This is high energy laser weapons are point target, and whereas high power microwave weapons are area target means they operates like a cone or a wide net, cone or a wide net which is capable of affecting multiple targets, which is capable of affecting multiple targets like a drone swan. Okay, simultaneously within its beam width, in its beam width only it can target the area or the drone swarms it can target. But this high energy laser weapons, what they do, they target only a point where we wanted to target, the direct point, okay, not the area. Next, coming to the atmospheric impact of these weapons, the HEL, the high energy laser weapons, they are highly vulnerable to weather, means like rain, fog, dust and atmospheric turbulences scatter the beam and drastically reduces effectiveness. It scatters the beam and reduces the effectiveness. Coming to the high power microwave weapons, whether they are weather resistant, they are not the HELs are not weather resistant, but these HPMs are weather resistant, where microwaves easily penetrate into fog, rain and clouds without significant loss of power. Next, coming to the range of these missiles, these weapons, generally longer range but diminishes based on atmospheric clarity. It means generally a long range only, but it diminishes based on the atmospheric turbulences and atmospheric disturbances. It may distract the target also, distract the range also. Okay, by whom? High energy laser weapons. When coming to high power microwave weapons, its shorter range, the electromagnetic beam naturally widens and weakens over long distance. It widens and weakens over the long distances. Okay, these are the few differences between the high energy laser weapons and high power microwave weapons. Okay, next, moving forward, see what is the India's key DEW programs. India's key DEW programs. India is aggressively pursuing DEW self-reliance under the Atmanirbhar Bharat initiative. Atmanirbhar Bharat initiative, primarily led by the DRDO Centers for High Energy Systems and Sciences and the Laser Science and Technology Center. Okay, next, coming to Durga. Okay, directionally unrestricted ray gun array. Directionally unrestricted ray gun array. Okay, this is what the Durga's full form is. It is an India's flagship high energy laser program. High energy laser program which initially tested at lower kilowatts. Now the Durga 2 is lethal for 100 kilowatt system capable of burning through incoming missiles mid-flight. Incoming missiles in the mid-flight. Okay, next is Kali. Kali is kilo ampere linear injector, which is a prominent Indian high power microwave project. Okay, it is designed to emit powerful burst of microwaves to destroy the electronic circuitry of incoming enemy aircraft and missiles, rendering them inert. Okay, and the next one is Project Trinetra and Sahasra Shakti. Project Trinetra and Sahasra Shakti, which is earlier and ongoing framework for testing tactical ground-based laser systems, which aimed at countering short-range asymmetric threats. Okay, next, coming to the strategic advantages of this DEWs. One is what are the advantages? The first one is speed of light delivery, where immediate engagement, once fired, the energy reaches the target instantaneously making evasion impossible. Okay, next, the next advantage is virtually unlimited magazine. As long as there is a continuous supply of electricity, as long as the electricity is supplied via generators or ship engines, the weapon will not run out of ammunition. Okay, next, extremely low cost per shot. Per one shot it is extremely taking very low cost. Like firing a laser costs only the price of the diesel or electricity required to generate the beam, effectively reshaping the economics of defense. firing a $1 million interceptor missile at $5,000 commercial drones is economically unstable. Okay, so this DEWs will solve this. Okay, next advantage is precision and low collateral damage. Precision and low collateral damage, like surgical strikes on specific parts of a target, like an engine, without the explosive fragmentation of kinetic warheads. Okay, these are the few advantages of DEWs. Okay, next let's see few operational and technical challenges of it. First is the thermal management. Like how generating 100 kilowatts of laser produces massive amounts of waste heat. It generates massive amounts of waste heat, which is developing cooling systems like active water cooling to prevent the weapon from melting itself in extremely complex temperatures. Okay, next the next technical challenge is line of sight limitation. Like, because light travels in straight line, basically the light always travels in the straight line, right? So DEWs cannot shoot over the horizons or over obstacles like cruise missiles. Okay, next is the atmospheric thermal blooming. It is a phenomena where the intense heat of the laser warms the air it passes through, which ironically defocuses and bends the beam, which reducing its power on the target. Okay, next, these are few operational and technical challenges of the DEWs. Now, what is the global landscape of it? Let's see. Coming to the United States of America, it leads globally with naval deployments like Helios and HPM systems like Thor, which is specifically for drone swarms. Okay, next, coming to Israel is preparing to deploy the Iron Beam. It is preparing to deploy the Iron Beam, which is a 100 kilowatt laser to complement its Iron Dome, specifically to shoot down cheap rockets and mortars. Okay, next, coming to UK is developing the Dragonfire laser system. The next is Russia deploys the preserved laser system, which is primarily used to dazzle or blind the optical sensors on enemy spy satellites. It blinds the optical sensors on the enemy spy satellites. Okay, these are few global challenges and the operational and technical challenges what we are facing indigenously. Okay, next, moving on to our next topic. Our next topic is anti-drone technology. Why this anti-drone technology is in news means the Russia-Ukraine war, which is held in 2025 to 26, this conflict has cemented the era of asymmetric warfare. This conflict has cemented the era of asymmetric warfare. During the winter of 2025-2026 alone, Russia launched nearly 1,900 attack drones, which is including Shahed loitering munitions at Ukraine infrastructure. Okay, this has accelerated global demand for affordable counter unmanned aerial systems. Okay, basically we know, right, the Russia-Ukraine war, which has gone very severe and all, so that is what it's been explaining. Okay, next is the border surveillance and internal security. By the first quarter of 2026, the Border Security Force, the BSF, reported a massive surge in the seizure of compact weapons and narcotics dropped by rough drones. Narcotics which are dropped by the rough drones across the India-Pakistan and India-Bangladesh borders. Okay, which is highlighting a critical urban and border security threat to India as well as into India. Because see, this many drones, they have dropped this narcotics and all in the India, Pakistan and India, Bangladesh border in the 2026 quarter of the 2026. Okay. So this is why these are in, this anti-drone technology is in news. Okay. Let's see what is anti-drone system. The anti-drone system or counter UAS is a multi-layered technological framework designed to detect, track, identify and neutralize the hostile or unauthorized drones. Okay, basically for drones, because coming up with drone technology, we are facing many advantages and disadvantages as usual. Okay, now this is where the anti-drone system or counter UAS is a multi-layered technological framework which is developed to destroy, detect, track, identify and neutralize the hostile or unauthorized drones. Okay, in few areas we don't have the, we don't have that this to fly these drones and all, right? We can't fly the drones in the few areas. Even in our Hyderabad also we can't do that. Okay, next, coming to the, because drones are often too small, slow and low flying. They are too small, slow and low flying to be picked up by conventional anti-aircraft radar, which is specialized CUAS networks are required for it. Okay. Next, coming to the detection phase, which relies on overlapping sensors and the blind spots, we'll see the first one is radar, which is the active phased array radars. The active phased array radars can scan for the physical movements and cross sections of nano or micro drones. Normal small drones are also has come up, like, so radars which are active phased array radars, they can scan for the physical movement and cross sections of this nano and micro drones. Okay, next is the radio frequency sensors. What does this radio frequency sensors do is, they detect the communication signals, and telemetry data passing between the drone and its pilot. Okay, next is electro-optical and infrared. What does it do? A thermal and visual cameras that confirms the target visually even at night. Even at night time also they confirms the target. Okay. Next, coming to the acoustic sensors. Like, these are the microphones which are designed to pick up the specific buzzing frequencies of drone propellers. Okay. These are few detection phase relays. Okay. Next, coming to the neutralization, neutralization of soft kill versus hard kill. Because see, soft kill is the electric warfare and hard kill is the kinetic or physical one. Okay, let's see the differences between these two. Coming to the mechanism of this, the soft kill which is used in the electronic warfare is, it disrupts the drone's operation using non-kinetic electronic or cyber means. Okay, coming to hard kill, it physically damages or destroys the drone using the destructive forces. Coming to the techniques, in soft kill what it is used is RF jamming. RF jamming is used, which serves as the link between the drone and the controller. Next is the GPS spoofing. GPS spoofing is feeds the drone fake satellite coordinates and forcing it to crash or land safely. Next is protocol takeover. It hacks the drone system to gain pilot control. Drone systems to gain the pilot control. This is what the techniques which is used in soft kill. Coming to the hard kill, it uses high energy lasers which melts the critical components, of the drone. Next is the microwave weapons, which fires internal electronic circuits permanently, which destroys the drone completely. Okay, and the kinetic interceptors, what they do? They nets shotgun blasts or interceptor drones or missiles. Okay, next is the best use case. Where is this soft kill is best used is, it is used in urban areas, airports and public events where falling debris, collateral damage is a major risk. Next, where is this hard kill neutralization of the drones is used is in military zones, border defense and high threat scenarios. Example, weaponized swarm attacks. Okay, next, coming to the cost, the soft kills are generally highly cost effective and reusable, whereas the hard kill are expensive, especially specifically the missiles, through lasers or bringing the cost per shot down significantly. These are the primary neutralization methods for the drones, where the UPSC, in your UPSC prelims, you can expect questions. Okay, next. Now, what are the India's indigenous anti-drone ecosystems? We'll see. India's indigenous anti-drone ecosystem is with a heavy push for self-reliance, in defense. Key developments are emerging from primary research hubs, notable the DRDO laboratories situated in Hyderabad and Bangalore. Okay, next, the DRDO D4 system, which is drone detect, deter and destroy. Okay, this is an India's flagship program which is integrated anti-drone system accepted by the armed forces. Okay, it provides a comprehensive 360 degrees shield. Next, coming to the dual capability, it can instantly jam micro drones. It can instantly jam the micro drones using RF and GPS spoofing. That is the soft kill, and utilizes a laser based direct energy weapon like the hard kill to physically burn the target. That is the hard kill. It ranges up to 2 to 3 kilometers. Okay, next is the Bhargavastra and Indrajal. These are emerging indigenous systems. And autonomous AI driven drone domes. These are AI driven drone domes. Okay, which is designed to protect vast areas like thousands of square kilometers. Not only 2 to 3 kilometers, thousands of square kilometers have been covered by this. Okay, from swarm attacks, moving away from point defense to area defense. Okay, next, coming to the vulnerability of it, a major ongoing challenge of these systems is detecting and neutralizing highly autonomous drones which do not rely on GPS or external pilot communication, which is the rendering traditional RF jamming useless. Okay, this is the vulnerability and few India's indigenous anti-drone ecosystems, and we have seen few like DRDO D4 systems, like dual capability of it, and we have seen Bhargavastra and Indrajal projects which have been upcoming. Okay, these are the topics for the defense roundup for today. We have seen few defense related topics and the drones and all. So I hope everyone liked this session. To have a complete note on it, do visit our website and download the content from there, and do like and subscribe our YouTube channel, and do follow our Instagram and Telegram channels for your UPSC preparations. And I'll see you all tomorrow with another content of science and technology and environment related current affairs. Thank you.